Good morning. We are SADI Control Systems, a team of 6 Aggie engineers revolutionizing the fire sprinkler industry. So with a show of hands, who here has triggered their smoke alarms because they burnt their food? So you know those alarms are going to eventually turn off. But let's say you've put your toast in for too long, your toaster goes up in flames, and then boom, fire sprinkler activates. Those flames are going to be quickly extinguished, but that water is going to continue to flow. So why can smoke alarms turn off on their own, but fire sprinklers can't? Well, our company has the answer to that question. Our prototype, SADI, adapts, applies, and advanced NASA technology to provide an asset-saving alternative to current fire sprinklers. But what's the issue with sprinklers to begin with?
So, why is it that we need an alpha feature? You see, fire sprinkler technology has been around for almost 200 years. It's been doing its job great, and we do not want to reinvent the wheel. However, we do want to solve a problem that most people are not aware of. Our problem is water damage. Picture this. You own a high-rise building and a fire breaks out on the 40th floor. A fire starts, and then the fire sprinklers actuate. They will start spewing out a staggering 15 to 50 gallons of water per minute each. This will effectively put out the fire in the first 15 to 30 seconds. So far, so good, right? Well, you see, after that, there's a period of anywhere between 10 to 30 minutes where the fire department has to arrive on scene, make sure the fire is out, and then proceed to turn off the water manually. During this time, hundreds if not thousands of gallons of water are poured out into the building, causing millions of dollars in property loss. With our product, we're using shape memory alloys, or SMAs, which are a material that react physically to a change in temperature. This material is perfect for our application since we have no electronics, no complex mechanisms, and minimum failure points. Due to the fact that SMA is our sensor, our logic, as well as our actuator. But how can we apply this wonderful technology?
Alright, so as Fernando said, we can use shape memory alloys, or alloys that respond to a change in temperature by changing their shape to help us with this problem. So we were inspired by this NASA patent here. This is a valve that is to go on a NASA propulsion system that is normally open and then it shuts off once the transition temperature of the shape memory alloy has been reached. And we took this design and then we applied it to fire safety. So, as you can see, a traditional fire sprinkler has no way of turning off. Once this little bulb here has been exploded, it's just an open pipe, and it continues gushing and gushing water even after the fire has been extinguished, until the fire department can arrive on the scene, verify that the fire has actually been extinguished, and then shut off the valve manually at the fire sprinkler. In contrast to this, our prototype here has an SMA Actuated valve that will interrupt the flow of water once the fire has been extinguished. So let's take a closer look at this design. Fernando here is going to demonstrate this design with this simplified prototype. So we're going to take a look at what it looks like when it's sitting idle, what it looks like when there's a fire, and what it looks like after the fire's been extinguished. So, if you take a look at this upper left diagram, we have a pin right here that is holding the valve normally open. This ensures that the valve stays ready and is always in a state of readiness to deploy water if it is needed in a case of fire. Now, if you take a look at the second picture, you can see that we are also using a bulb just like a traditional fire sprinkler to activate the valve. This means that we can expect the same safety and reliability from this prototype as we can from these traditional fire sprinklers. Now, what happens when there's a fire? So this bulb explodes and the SMA is contract, pulling the valve and keeping it in its open position. This allows the water to gush out and quench the fire. So after the fire has been extinguished, what happens? This is where something different happens from traditional fire sprinklers. So you can see the shape memory alloy pulls, it makes the plunger push into the flow, stopping it and preventing water damage. So what have we done? We've created a prototype that has the same safety and reliability as traditional fire sprinklers that we know and love, and it is able to prevent the water damage that happens in the aftermath of a fire. Experts believe that this prototype has massive potential in the fire safety industry.
So as Joshua was saying, after we did some initial prototyping and development, we sought relevant endorsement. Here we have a quote from College Station Fire Chief Richard Mann, who also served as your Vice Fire Chief for 31 years. This makes him eminently qualified to discuss how necessary our product is. We also got the chance to meet with the National Fire Sprinkler Association's Chief Engineer, with whom we discussed various rules and regulations and previous attempts made to have a self-closing fire sprinkler. So now we're going to get into our market analysis and conditions. As we do that, please keep this question in mind. How many fire sprinklers are in this room right now? Because usually it's a lot more than you think. In this room, I counted 19 fire sprinklers. If you multiply that across the thousands of rooms just like it in the country, you can get an estimation for how big our market size is. In the last year, 40 million new fire sprinkler heads were fitted into buildings across the country. This contributes significantly to our overall market size of $8.1 billion.
So the fire sprinklers in this room are actually hidden under the caps, which is why you couldn't see them. But, so as Neel said, there is a large and diverse market for SADI control systems. We can go into residential buildings and we can protect personal property. We can go into industrial and prevent employee relocation. We can go into commercial and also prevent inventory loss and economic impact. Additionally, we are seeking to partner with insurance companies to cut down water damage payouts and lower insurance premiums. Some of our stakeholders are customers, distributors, insurance companies, and investors, as well as regulatory authorities. So as for some tech industry impacting factors, we have seasonality, and as for us, there is no better time to have SADI than always. Where and when you see a sprinkler, there is a need for SADI. Technological would simply be that we want to find a seal that ideally shuts the water off completely, but even finding a seal that cuts down the water flow by 50% is already such a significant win for us. And additionally, SADI was made with regulatory compliances and fire safety codes, so there is no modifications that need to be made because these typically do not vary by region. So to characterize who we want to be in the industry, we looked at companies in the industry and kind of saw what we wanted to emulate. We want to be a global manufacturer like Johnson Controls, allowing us to provide unmatched quality as well as remain industry-minded because it is a smaller industry that we are dealing with. And initially, we'd like to be vertically integrated to facilitate modifications to our product so that it can be the best it can be. And that allows us to adhere to our timelines.
All right, moving on to our timeline. This year, we have begun and will continue to research and prototype our designs, as explained earlier by Josh. Next year, we will be undergoing our testing and optimization, while also ensuring our compliance with regulations in place set by organizations such as the National Fire Protection Association. In 2026, we will scale up our manufacturing, our logistics, and our marketing to ensure a successful launch of our product that same year. And then in 2027, we will ensure post-launch customer support to ensure that any issues that do arise are patched. Moving on to our finances, we are asking for $900,000 to cover our startup and our first year of operations, our production costs of $8.50 per unit, as well as our retail price of $13, puts us needing 70,000 units to break even and begin returning on our investments. And I'll pass it to Jireh to wrap us up.
All right, thank you, Roman. So by leveraging NASA technology into our SADI prototype, we can prevent millions, if not billions of dollars in asset loss. Think about the substantial societal impact sprinklers have. Think about how it's time that we have smart sprinklers. Think about SADI and how we're doing just that. So we hope you're fired up about joining us in our journey. Thank you.